Our story begins with a young AB calculus student learning her derivatives with her sister. However, to Angie, this math seems too simple and she swiftly falls asleep. Suddenly, she sees a white rabbit running by, and wanting to know the rate at which it's running, she follows it and finds herself in a mysterious BC Calc land. Angie follows the rabbit down a rabbit hole and falls and falls and falls until she makes it into this strange Calc land.
Oh, where'd the rabbit go? What's this door? Oh, there's a garden. And there's a key. But I'm too big to fit through the door. What's this? Huh. Drink meat.
So Angie needs to drink the potion. The rate at which Angie grows is inches per milliliter. The function is defined by -5/2x² plus 15x is equal to her rate. So if we want to find out how much she needs to drink to go from 65 inches to 25 inches, we have to integrate this rate function. We are able to determine the function of her height as -5x plus 15 plus c. C is equal to 65 inches because this is her initial height. So now we want to set this new function with C plugged in to equal 25 inches, which is her final height.
Yes, now I can get through the door. Oh, but the key! I can't reach it! Huh. Maybe this will make me bigger.
Oh no, Alice forgot to get the key. So now she needs to eat the cake to become bigger. So the rate at which she grows is defined by the function 30x over 1 plus x squared is equal to her rate. So in order to find out her height, we need to integrate it. So we integrate it from 0 to 15, and setting u equals 1 plus x squared and du equals 2x plus dx. So now making everything in terms of u, we find out that the function is actually 15 ln u from 0 to 15. She becomes 40.6 inches, big enough.
Now I'm too big. What did I do wrong in my
Oh no, what did Angie do wrong? Aha, she forgot to change her boundaries when she converted everything to u. So now u actually equals 1 plus x squared. So if we sub in 15 and 0, we get that the actual boundaries are 226 and 1. So now plugging it into the equation, we get that she actually becomes 81 inches. She's way too big.
This place is so strange. Hello? Hello?
Who are you?
Why?
Who are you?
I don't know. I was doing calculus and then I'm in AB, but I want to learn BC. I don't know what I should do.
Why are you here?
I don't know why I'm here. This place is so strange. There's math everywhere.
Well, I will show you a BC calculus problem, and let's see if you can handle it.
I think I can do it.
Sure about that?
Now Angie will try to solve the caterpillar's problem. So she has to approximate the integral from 0 to 1 of this function. Now in order to do this, she has to split the function into two integrals. So the integral from 0 to 1 of the first function minus the integral from 0 to 1 of the second function. Now she knows the Maclaurin series for cos of x and sine of x are these functions. So first she solves she puts 6x cubed inside the Maclaurin series for cosine of x, and then she multiplies this out, and then she multiplies the Maclaurin series by the function that cosine of 6x cubed is multiplied by. Now she just does some basic arithmetic. So she's multiplying the numbers out. So now she uses the first fundamental theorem of calculus, and she plugs in 1 minus 0, and since the x's, when there's zeros, just turn to 0, you get negative 19 as your answer. So now basically she does the exact same thing for the second integral. So we know that sine of 7x to the fourth, you just plug in 7x to the fourth whenever there is an x in the Maclaurin series for sine, and you get this. And she multiplies that by the function that it is multiplied x to the fourth plus 2x squared plus 1. And again, she just does basic arithmetic and exponential mathematics. And so she's just adding these things up. And again, she'll use the fundamental theorem of calculus from 0 to 1. So she plugs in 1 to all the x's minus plugging in 0 to all the x's. And she gets 6,251 over 15 as her answer for this integral. And so then to get the entire integral from 0 to 1, we simply subtract we simply use negative 19 minus 6,251 over 15, and we get that.
Calculus.
Let's see, where was I going?
Integrals
Where do you suppose that's coming
by
from?
parts series.
Oh, you're a cat.
Indeed I am.
Well, I just wanted to know which way I should go.
Depends on where you want to get.
Well, I guess it doesn't really matter where I get.
Then it doesn't really matter where you go.
Oh. Well,
He went that way.
who did?
The White Rabbit.
He did?
Who?
The White Rabbit.
What?
Oh my, this is so strange here.
If I were looking for the rabbit, I would go talk to the Mad Hatter.
The Mad Hatter?
Yes,
Where does he live?
that way.
Oh, but I don't want to be around mad people.
Well, everyone's mad here.
What's that over there?
Oh, we're celebrating the non-AT days.
I agree.
Who's this? Who are you?
Oh, I'm sorry. I saw you were having tea. Can I sit with you?
We are Madness from Calculus BC, coming here to answer and test for D. What is the integral of cosine EX plus 3? Answer correctly to come and drink tea.
Why Mad Hatter? That is too hard. She's only an AB. What's the derivative of cos 3x plus E? Answer this and sit with me.
No, guys! Alice, please find the volume of the cake first!
Well, I don't know if she can handle it, but we shall see. Parabola shape.
The function of the cake is defined by the function negative x squared plus 5x minus 4. This intersects the graph at x equals 1 and 4. So using Searle's method with the equation 2 pi times the integral from a to b of the height times delta x dx, we are able to plug in our function into Searle's method's function and find the volume of the cake. After plugging this into our calculator, we find that the volume of the cake is 70.686 inches cubed. However, if we want to do it without the calculator, we can use the reverse power rule to integrate. Then we find that the function after we integrate is 2 pi times negative x to the fourth over 4 plus 5x cubed over 3 minus 4x squared over 2 from 1 to 4. So then using the first fundamental rule of calculus, we plug in 4 and 1 and subtract them too.
This place is so strange. How can we live here?
Because we are in BC.
And you're only an AB. We're all mad here.
Celebrating the non-AP days.
What's a non-AP?
AP only occurs one day in the year. We're celebrating the non-APs.
Oh, I see. Then I guess it's non-AP day for me too.
No, because you're an AP.
There's a difference.
Who goes there? Me. Angie. Off with their head. No, I'm so sorry. I didn't mean to intrude. I just saw your castle and you look so smart.
Well, I might let you go if you play croquet.
I do play croquet very well, actually.
Well, let's just play.
Okay.
Take one.
I've played croquet before, but never with these.
Oh dear, we play with integrals.
Okay.
Let the games begin. Was a fair shot. Now it's my turn.
Oh, it's in!
We know the constraint of the hoop is 18 meters of wire surrounding the hoop, so we set that equal to the perimeter equation, and then we solve for h. Next, we find the area equation of the hoop. After that, once we found h, we plug that back into the area equation. Next, we take the derivative of the area. After we found the derivative, we must now solve for r. Now we figured out that r is equal to 2.44, but we must prove that it is the absolute maximum by plugging it into a sine line. Now we know that it is a maximum. So we plug r back in for h into the h equation, and we figure out that h is equal to 1.7475. After, we plug h and r into the area equation, and we finally figure out that our area is 43.9746 meters squared.
But you were cheating.
Off with
There is always something to learn in the class of BC Calculus. Oh no, AB kid, we can't pretend that you know as much as we did. There's something to say for an integral, for taking the area under a curve. I promise it won't be dull. Just try to be calm in your nerve. This class is not a paradise, if indeed it ever was. It's a vale of tears, and so, my dears, I know you will not recognize. Low D high minus high D low over low D low is all I really plead. Nothing to say for parts, just look at this simple little chart. UV minus integral V du is what you do when integrating two functions at a time. I know you're really smart, so listen to your heart and forget about AB and just take BC.
Angie, wake up! Come on, we have to study for the AB test.
No, I want to take BC. Welcome to the tea party.
Hold on. It's not focusing. Okay, anyways, just go on.
Depends where you want to go.
Stop, Nancy,
The rabbit went that way.
Nancy, why are you idiot. Like, literally, we just went over your line. Depends which way you want to get. You, Nancy. The rat one. If I were looking for the white rabbit! No, he went that way if you want to know. Ah! Yeah, you really messed up, but that's okay. That was fine. No, you skipped half your life! What other life do I have? No! Help me! My life! Wait, help me some more of this.
This is going to the bloopers.
Okay, ready? Are you ready? We need to film! Switch feet here, I got you. Ready? Go! Ready? Okay. Hold on, use your arm strength! Okay. Alright. Ow! Let's hurry up and film this song! Please, we need to film, but she's gonna die!
Okay.
Like, is it hard to improvise? What was happening? Do you play crochet? Sock, are you
Go pick it up and put it.
Okay, we need to do this again because obviously you guys don't know. So you can't hit that. I'm telling you, we'll knock it with a. Son, what the?
Flashing lights on me, took a wrong turn we fell down a rabbit hole. You held on tight to me, 'cause nothing's as it